Hello everyone, this is Amita from AIDS department. Now we are going to see about encoder and decoder. First we can see about encoder. Combinational design procedure. Digital encoders produce outputs of 2-bit, 3-bit or 4-bit codes depending upon the number of data input lines. An n-bit binary encoder has two n input lines and n-bit output lines with common types that include 4 to 2, 8 to 3, 16 to 4 line configuration. The output lines of a digital encoder generate the binary equivalent of the input line whose value is equal to 1 and are available to encode either a decimal or hexadecimal input pattern to typically a binary or BCD. This is the block diagram. Objective. An encoder has two n input lines and n output lines. In encoder, the output lines generates the binary code corresponding to the input value. In octal to binary encoder, it has 8 inputs, 1 for each octal digit and 3 output that generate the corresponding binary code. Input and output variables. Input variables are y1, y2, y3, y4, y5, y6, y7. Output variables a2, a1, a0. This is the truth table for encoder. This is the circuit design. This is the components required: NAND gate IC7410, OR gate IC7432, NOT gate IC7404. Decoder. Combinational design procedure. Determine required number of inputs and outputs from the specification. Derive the truth table for each of the outputs based on the relationship to the input. Simplify the Boolean expression for each output. Use Karnaugh maps or Boolean algebra. Draw a logic diagram that represents the simplified Boolean expression. Verify the design by analyzing or stimulating the circuit. This is the block diagram for decoder. Objective. A decoder is a multiple input, multiple output logic circuit which converts coded input into coded output where input and output codes are different. The input code generally has fewer bits than output code. Each input code word produces a different output code word such that there is 1-to-1 mapping and can be expressed in the truth table. Input and output variable. Input variable E, A1, A0, output variables Y0, Y1, Y2, Y3. This is the truth table for decoder. This is the circuit design. Components required: NAND gate. Now we are going to see about encoders. Place 3 input switches. Two OR gates and 2 output bulbs. Let's start labeling. Label the first switch as Y1, Y2, Y3 and the 2 output as A1 and A0. Let's start connecting. Connect Y3 to Y3 to OR gate and Y2 to OR gate and Y1 to another OR gate and Y3 to another OR gate. The output of the OR gate is connected to A1 and another output of the OR gate is connected to A0. Now if we switch on Y1, the result would be 0, 1. If we switch on Y2, the result would be 1 and 0. And if we switch on Y3, the output would be 1, 1. If place 4 NAND gates, 2 switches, and two NOT gates. And connects switch with the NOT gates, both the switches with the NOT gates, and the output of the NOT gates and the output of the NOT gate to the NAND gate, and the second output of the NOT gate to the NAND gate, and connect this first switch to the second NAND gate, connect the second switch to the second NAND gate, and second NAND gate to the output of the first NOT gate, and the first switch to the third NAND gate, and first switch to the fourth NAND gate, and output of the second NOT gate to the third NAND gate, and second switch to the fourth NAND gate. Place 4 bulbs for outputs, and connect the output of the NAND gate to the output of the switches, output of the bulbs.